Welcome to the BNS on Aerospace and Defense podcast series. I'm Pat Hindle, Media Director at Microwave Journal and Signal Integrity Journal. I'm joined by our host, Brian Goldstein, President, Analog Devices Federal, Vice President of Aerospace and Defense Group at Analog Devices, and Sean Darcy, Senior Director of Aerospace and Defense at Infineon. And today we have a special guest, Russ Garcia, CEO of Menlo Micro. Welcome, everybody.
Hey, thank you.
Thanks, Pat.
Well, it's been some time since we did our last episode, so I thought we'd talk about a great topic here. We're going to talk about reinventing the semiconductor supply chain with the CHIPS Act and onshoring. And here I think Russ has some great insights since he is kind of in the middle of that. And so I thought we would kick it off with him. And Sean, maybe you can kick us off with the questions.
Sure. Yeah, thanks, Russ, and welcome here. I think, as Brian mentioned, he and I used to work together. I have done actually a lot of MEMS in my past, both inertials, but also some MEMS switches. So really going to be curious to hear what you're going to talk about today. So let me start off just by having you tell us a good bit about your MEMS technology, what you guys are doing, and then some of the requirements that you need to produce them.
Okay, great. So first of all, let me give you just a quick background on Menlo. We've been around about 8 years. We took the technology out of GE Research in Niskayuna, New York. And as a backdrop to kind of understand what the manufacturing challenges are, but what we're solving, it's helpful to have a little bit of the history. And so what GE set out to do actually 20 years ago was not manufacture switches, but reinvent the circuit breaker, and actually went through basically the device that Thomas Edison invented and patented over 150 years ago. And so the bottom line physics behind it is put many small elements in parallel. I'm going to switch faster and more efficient, transfer energy more efficiently with a metal contact switch in a MEMS device than I can in a large electromechanical wire wound driven electromechanical device. Subsequently, they went out to you guys were probably, some of your teams were certainly involved back in that day. There was a bunch of startup companies, several large companies who were off looking at how to create this same brass ring, because it's not like GE came up with this idea all on their own. There was quite a few companies trying to make metal contact or ohmic contact switch MEMS. As you know, most of those were not successful. I think ADI can at least claim that they stuck it out the longest of most everybody in at least the large semiconductor companies. But the biggest issue in that whole experiment was that the materials being used to build these MEMS devices in semiconductor fabs were not conducive to making a reliable switch, meaning a switch that didn't have stiction or a switch that didn't have beam fatigue or contact issues and wear issues, or basically reliability issues. And so GE basically took their team of material scientists that do the metallurgy for the fins on aircraft engines, combined them up with the gentleman who's our CTO today, Chris Keimel, and said, let's solve this problem, make a reliable material. So first and foremost, and key to this whole supply chain issue for us, is this is a material science play. So they basically came up with an alloy. We actually have a couple of them now, but an alloy that gave the electrical properties that we have, as well as the ability to get billions of cycles in a very reliable, robust switch, number one. And number two, it allowed the switch to be a very simple cantilever beam, which has been one of the big issues. And subsequently, that allows us to have a manufacturing process that we can be somewhat analogous to a typical semiconductor process, where we can make a unit cell transistor, or what we call a mechanical transistor, that we can then replicate over and over again. One of the problems with MEMS, I think, is, as gentlemen know, is that a lot of times, every time there's a new MEMS product, there's a whole new MEMS process. And so our goal here was to be able to make RF devices and power devices with the same mechanical transistor, if you will, depending on how you laid that out. that's a little background there. Our first product areas and product traction has been around RF. Subsequently, we have a very low loss contact switch that's linear. It's basically a wire when it's closed. And so we have an excellent linearity, I guess is what I should say, over from DC to millimeter wave. And we can handle a lot of power, RF power as well. So that's been the first area of traction for us. We just actually did a press release yesterday on our power device and in a contract that we have with the U.S. government with the Defense Innovation Unit for a 10,000 amp, 1,000 volt circuit breaker system, of which our 10 amp, 300 volt device is actually the core of. So on the other side of the thing, the original intent and vision that GE had was this the reinvention of the circuit breaker. And so those are the two key areas that we play in.
That's really interesting. Thank you for that background. Can you talk about the fabs and what fabs are you internal, external, those locations?
One of the most interesting parts of this job, as you can understand, as a new material science, just being able to run down to anybody from Global or Skywater, TSMC, that is not a CMOS process and subsequently not compatible. Second piece I didn't mention, because of all the properties you would understand, we actually build this on glass substrates, and it's glass substrates, glass packaging. So we first started with the small R&D fab in Schenectady. I would advise, and probably would have gotten this advice from all you gentlemen: don't try to run production in a research fab. But we did. The good news was we proved that we can make this work. Immediately as we spun the technology out of GE in December 2016, we had actually, probably the 6 or 9 months before that, been searching for, we're going to have to find a fab to commercialize this thing. So, there's not a whole lot of MEMS specific fabs, especially, but there is a couple of boutique fabs where we could run glass, where they do have the electroplating capabilities that we were looking for. And so our first fab, and we're still there right now, is Silex in Sweden. And Silex is, as you know, one of the larger, I'll call it merchant fabs for MEMS, but a merchant fab for MEMS is a boutique fab by any other measure. Outstanding engineering capability, but the biggest thing was they aligned with the equipment set that we needed the most. So as a new company, as you know, capital is the biggest issue, and so that alignment was pretty important for us to get the device and product commercialized.
Very interesting. And so you're building your own fab now? Is that what the CHIPS Act is all about for you?
Well, there's a number of reasons for us to build a fab. One is that, for some of our initial RF products, and certainly as a young company, as you're in single digits growing to double digits and ramping that revenue, the capacity requirements and most of the products that we're doing are fairly high value products, didn't drive the need for the fab. However, if you can imagine, if your vision is circuit breakers, obviously you're not going to stay in a boutique fab. And even what we've done in Ithaca is just the first step of what's going to be required volume wise. But we knew we needed to move into something that was going to be at least give us the first level of scalability. So that's important. The second piece that's important is as, and both of you being involved in the aerospace and defense arena, a lot of our initial products are with the U.S. government. And one of the issues that exists at Silex is it's Chinese owned. And so the combination of needing to scale and that Chinese ownership led us to, actually, before the CHIPS Act was even law, but however, I think the DoD and the government had been pretty clear about where it was on supply chains and supply chain control. And then as we headed into COVID, we realized our supply chain was not compromised, but certainly not as strong as it needed to be. And so we started looking for a fab. we went through everybody who builds semiconductors. Our goal actually wasn't to own a fab. As you know, that's certainly, back in the day, real companies had fabs. And, back when I was first started in this business, and now it's more like you'd be nuts to have one. So, but we have to. The capital requirement to get allocated clean room space from a foundry, a real foundry or scalable foundry, I guess is what I should say, is higher than what we can do actually on our own at this point in time. Now, my expectation is as this becomes more and more of a mass market capability, and you start moving from a couple few thousand wafers a month into tens of thousands of wafers a month, I think at that point in time, the attractiveness to partner on the foundry side of the business becomes real. But those were the original motivations to move to reshore this. The first piece of this, and I know you're going to ask, well, why New York? We picked New York because one, we looked everywhere. We looked at California. I'll be quite honest with you, California is not interested in manufacturing. We looked at Texas and Arizona, two very typical places. I was lucky enough to get invited to the Super Bowl a couple of years ago, so that was kind of cool. But other than that, we don't move the needle there. And those guys were spending a lot in attracting all the large deals that you've seen. We spent some time even in Indiana. However, our roots are in New York. We have a research center already in Albany at SUNY Polytechnic. And number one, the technology came out of Schenectady right down the road. Third piece is the state actually has been very, very helpful for us. And I think they're, as you can see, they're I think they're being very successful in building, their Silicon Corridor. We're kind of the anchor in the southern tier. And, Pat, you know that area. You went to school there right next to Cornell in Ithaca. Senator Schumer, the rest of the call them the New York politicians have been really, really helpful for us. We received an incentive from the state to be there. All those together, plus this is the Goldilocks fab. We actually call it, as you may know, we shouldn't assume, but we've been branding our switch the Ideal Switch. We now call this the Ideal Fab, and basically, I think we started calling it the Goldilocks Fab. It's just the right size. We can't facilitate something that's going to do 10, 20,000 wafers a month right now. With us being able to get to that magic number of 1,000 to 2,000 wafers a month, where you've proven that the technology can really start to scale. That's the first step, and that's what this fab will allow us to do.
Can you talk a little bit about the process of working with the government? You mentioned working with the state. You also had to work through the CHIPS program office. Can you talk a little bit about that process and how that went?
I can tell you that we have multiple engagements going on right now with the Department of Defense, the Department of Energy, and Department of Commerce, based on really where the products come from and what we're targeting. We basically, our first RF device is right in the middle of the supply chain to test AI. So that's an important piece. Number two, I guess I should put it this way, we believe, I think that's been validated, that this is key to national security. We have a couple of contracts where we're doing some RF devices for various satellites and comms kinds of activities on the RF side. And of course, then the announcement yesterday, which is actually a large power device for the government. So what I can say is we started engaging with everybody from Commerce to the Hill before CHIPS was even law. And I think that's a real important aspect, because we are the true epitome of the tweener. If you look at CHIPS at its kind of visionary level and what they were trying to accomplish, we always talk about the valley of death. I called it the chasm of death one time, and they went, "Oh my gosh, that's worse than it is." I said, "Well, no, not really." But the CHIPS was set up for, and I think it's accomplishing its task for first bringing advanced, in all of our eyes, I guess, single-digit nanometer CMOS technologies to drive AI and advanced computing and all of that kind of stuff is super important. Number one, and it's very important for the U.S. to be a leader in development and manufacturing that. So that was one key purpose. The other key purpose was all the R&D efforts going on. But all of those R&D efforts are, and those are being funded, are pre-manufacturing in most cases, or get to leverage off of global and TSMC and all of those things. We fall right smack dab in the middle of that because we're not a CMOS process, but we are an advanced technology that actually is very, very disruptive into a couple of key markets. So we've had to make sure that we stay on everybody's radar and they understand that. Number one, as a matter of fact, it was interesting. Some of our first meetings with the government was, gee whiz, MEMS has already been reshored. There's a supply chain for it. Well, all MEMS is not equal, right? Site times doesn't make what we make. ADI makes closer to what we make than anybody else, but that's not, that's a very captive supply chain, and so that's been a big challenge. Number two is we're in the midst of an early manufacturing ramp. That's the most, as you all know, that's the most dangerous time for a semiconductor company. And if you have to own that supply chain versus being able to leverage off a big foundry, the risk goes way up. The capital intensity goes way up. Now, one thing that is interesting about us, the capital intensity of this is substantially less than a CMOS fab. But it's 14 masking steps. We do build on glass, but doesn't pose any specific equipment challenges other than transparency. And it's a metal deposition process. So it's like we don't use super advanced lithography or anything like that. Plating the science of plating is pretty intricate in our fab, and those are some of the nuances there. It's not that it's this ultra complex capital. It's really it's very nuanced, but once you put it in place, I think scaling it is that because of the simplicity is there. So that's what gave us a premise. And actually, some of our investors, as you probably saw, we raised about $150 million. I think it was February of 22. And some of the investors were able to rationalize the return on capital for this kind of fab because of the high value products that we're making and the substantially lower level of capital requirement to get to scale made the return on capital pretty attractive as well. I know I answered way more than what you asked, so I apologize for that.
That's perfect. I tell you what, let's switch over to some questions about maybe the workforce and some other things in your new location. We've seen a lot of these IC fabs being funded, built around the U.S. I guess one of the questions there is, are we at risk of creating maybe too much supply? But also, tell us a bit about the challenges about getting a workforce. We've seen I think many of us have talked to other people who are standing up the facilities, and we feel there's a workforce challenge. So what's your thoughts and insights there?
So there's a huge workforce challenge. My challenge is slightly different. I'm building a fab that's going to do 1,000 to 2,000 wafers a month. It's a 10,000 square foot clean room, substantially different than what Micron's putting up in Syracuse or what TSMC's bringing to Arizona. However, the problem is still the same. It's not necessarily process engineers, although there's an issue there. It's all the way down to operators. And so what we've done, and this is one of the pieces that's most attractive about New York, is the university network and the community college network there is really, really strong. As a matter of fact, the private universities and the state universities work well together. The community colleges, we're tied into Tompkins Community College, which is right down the street from Cornell. Cornell's tied in with SUNY, some of the other university systems. So we've actually, even as a small company, already started working with them on how we're going to develop operators and technicians, even through the community college system. I think it's going to take, for the whole industry, this is like a 10, 20-year project. The country is going to have to stay, from an education system, stay in semiconductor industry, stay very, very focused on to not lose track because as an industry, we're way underwater as far as, the You look around, there's too many guys my age in this business, and we need to get more people, more of the younger workforce developed quickly if we're going to support this thing.
No, that's very helpful. I appreciate that. And I think we see that too across our entire industry. There's a lot of what they call us graybeards. So I understand.
I will say this, if you don't mind me interjecting one other thing. For us, though, is we did buy an operating fab. So we kept the core of those. So we have the core engineering folks. And I do think that we still have we have a different attractiveness than working at Micron or Global because we're small. We're very innovative. From the engineering side, we become really attractive because we're not just the next CMOS fab. Number one. On the operator side, there's kind of a local, I'll call it pod of skilled workforce that's been around that area. That's not huge, but large enough for us that we can draw from. And of course, being next to Cornell is helpful. And then our other shop in New York is right on campus at SUNY Polytech. So we've got a pretty strong internship programs and stuff like that. So we are a little bit unique, and the challenge for, like I said, for Micron and TSMC and those guys is a little bit different.
Can you talk about, is your plan to open your fab or to fill volume, or is it to keep it internal?
Right now, I'm mostly worried about getting my supply chain up. So if you looked at the grand vision of this thing, the volumes, we're not looking to figure out how we just capture a few niche volumes and sell the company off. We actually believe with the real heart and soul of the power side of this is like I said, circuit breakers. Well, why would you use this for circuit breakers? Anything that's normally on and where conductivity is the primary parameter for it is where we fit. And if you can, just to quote some of the metrics from the press release yesterday, if you can reduce the overall size of a 5 megawatt, 10 megawatt system by 5 times, that's huge. It's huge. It's huge for a naval vessel or an aircraft, but it's just as huge for an EV network. It's just as huge for building management. And so when you start looking at those applications, the volume for this stuff gets really big fast. And so, like I said, this is the first step of scale. It's going to take years to develop all that market, but we fully expect that we're going to be partnering with larger entities, both on a manufacturing side and a marketing side, because I don't believe that organically any small company can just own the entire world on something that's so. This is very horizontal. These switches are in everything, right? And so we believe we'll be brokering a lot of partnerships to build that scale over the course of the next 5 to 10 years. But this is a first step at 2,000 wafers a month, 8-inch wafers. So
Makes sense.
No, perfect. So I guess I'd like to close out with a question about, so what would you say to companies or organizations who are considering onshoring themselves and getting CHIPS Act funding, and maybe even about, how you worked with the state of New York funding, and, what kind of advice would you have or would you give to them?
Specifically on CHIPS funding, I'd say if you haven't started, then it's going to be tough. I think on 9906 R&D kind of applications are getting involved in a technology hub. I think some early companies, those activities are still available. It's really hard, however, to do it for small teams on this because the amount of paperwork and research and of understanding where things are landing is really difficult. And so without at least a dedicated resource that understands their way around Washington a little bit, it's really hard. That's one thing. But just the government in general, depending on what you're trying to do, if you're an early company, you've got a great technology idea, maybe you're building doing some research in a university or whatever, pick universities that are tied into these technology hubs and stuff, because there's a lot of leverage in that for companies like that. For companies more like mine, I think that you have to really understand what the problem set that any funding because there's multiple funding vehicles. CHIPS isn't the only one, but whether it's CHIPS or something else inside the government, what problem are they trying to solve? And are you a gap filler for that problem? Then you can go work it, but you got to be patient. There's almost nothing in there unless you're in rare earth metals or something like that. I think you can accomplish in less than a couple of years. This is not like, and it's not like raising from a VC standpoint. It's not like raising funds from a VC. There's processes in this thing, but there's so many fingers in the pot. That's, how many senators' offices do you got to go talk to their defense staffers and get those aligned with whoever's in the DoD R&E area or Department of Commerce or whatever. So you have to be committed to it. You have to be very patient, and it takes a long time.
No, perfect. Well, thank you. I think that's been some great insight. So appreciate you taking time to answer and enlighten us a little bit.
Oh, we really appreciate it, and we wish the best for you and your company.
Definitely.
Well, great. I enjoyed the time. I enjoyed the question. Appreciate it, and thank you very much.
Well, thanks everybody for reinventing the semiconductor supply chain advice. I think it was well worth it. And this wraps up this episode. You can find more episodes at podcasts.microwavejournal.com. And we thank everybody for listening today.